After this, what happens? These electrons and ions go where? Cathode or the anode. They are getting collected. It is generating what? It is generating charge. So Q plus minus sigma Q. Not a big deal. What is the Q and N relation?
Q is equal to NE.
Q is equal to NE. Pretty simple. Sir, give me the fluctuation, I will be able to tell you what will be the sigma Q as well. That's not a big deal. It's just a simple multiplication with the charge. Now, this is what the charge coming out of the detector. The first thing which I drew, so let's say I can actually start with an alpha, and this T alpha, which is all of the same energy. Single alpha particle comes, interact and gives you some kind of pulse. This is coming from the detector. Now what this pulse is showing? This is nothing but
Charge collected.
This is the first thing which comes if one of the alpha particle comes. What if second of the alpha particle comes? So that must be somewhere here. Third alpha particle here. Fourth. If the counts are separated out well, if the radiation rate is separated out well, then I can see each of this charge getting collected in one ring. Remember, I told you that for most of the detector, this is of the order of 0.1 to 1 microsecond. Keep an eye on. Okay. Now, why this looks different from this one? This is the second alpha particle which has come. I do not know from where in the detector it has passed through. Let's say the second thing comes and second one passes through the center of the detector. It is very close to my anode wire, which means all the charge will be instantaneously given. So the time is only this much. But it will still give me the charge which is somewhere in the sigma plus minus Q plus minus sigma Q. Not exact Q. Sometimes maybe Q minus sigma Q. Sometimes maybe Q plus sigma Q. But other times anywhere in between. Any pulse. So each of it is going to be integrated, since it's a current pulse. Each of them it is going to integrate to give you what? That is going to give you actual charge which is deposited in one particular alpha particle. Possible. Right? And that can be anywhere between Q minus sigma Q to Q plus sigma Q. Right? Now, this is what happens after the detector, which is what we actually go through after that in the electronics. Yeah? After that, what did we do? So we have two options: preamplifier, voltage sensitive and current charge sensitive. The charge sensitive one, if we take it, then in that case we output turn out to be minus Q over CF. My pulse is getting inverted, minus sign,
Inverting.
and then what? It is integrated over the fixed capacitor C. Right? So I am going to see a voltage pulse after that. So let's say if my first pulse was on the positive side, all I need to say is the second pulse from the P amplifier goes like this. So first one is going here, the second one increases, it goes here, the third one will start from here, fourth one it is still not decayed here, something like this. Why? Because the preamp, so this is Vt as the function of T. Voltage pulse which I am seeing, output. At what? At preamplifier, at detector. This is source. And I hope it is clear to you that E alpha is nothing but T alpha plus M alpha C square. It's pretty simple relation. This pulse is of the order of 50 to 100 microsecond. Why? Because of the feedback resistance. The feedback resistance which we employed so that the charge does not go and increasing step and then further. We wanted to decay, but we cannot decay it as fast as 1 microsecond. Then we will not be integrating the charge. And I have this problem that I have the noise issue and I have the width issue. At this point I say that we are going to use amplifier which is going to amplify. So if the charge is this, what is the voltage? Q over CD prime. This is the voltage at the detector. Right? This is of the order of microvolt to millivolt depending on whether ionization chamber is used or the GM counter is used, multiplication is inherent or multiplication is outside, whether semiconductor detector is used, large density, large electron hole pairs or scintillation. This depends on what kind of the CD is offered. Yeah? So this becomes millivolt to for sure. In the amplifier stage, even though you may see that I am plotting it, I mean the plots are on a different scale, this becomes the voltage level, V level, pulse. So amplifier is amplifying surely. It is doing my signal to noise ratio by rejecting noise, etc. But it is amplifying surely. Using which network? The one which we have done, CRRC network. Now again we are in the ballpark figure of 2 to 10 microsecond. So I can again distinguish these pulses. So I am just drawing the Gaussian similar, but okay, this may be slightly away from the Gaussian, etc. This is at the level of the amplifier. So this is Vt as the function of T, with the amplitude of the order of this. At this point I said that the problem related with the sharp, the problem related with the frequencies are taken care of. I am now going to employ a discriminator or a threshold which is basically a comparator, compares the amplitude with a given level and see whether this will be passed or not. Now, if it is alpha particle, for example, they are all of the same energy, right? So the result of each of this integral is Q plus minus sigma Q, right? So within some variation, they all will pass through a simple discriminator mostly. But within Q plus minus sigma, we do need to have some idea of what the sigma Q is. Right? So at this point I told you a comparator compares, a logic pulse is generated. The logic pulse was of the kind, so I am drawing the logic pulse here itself, which is a vibrator, multi-vibrators, a simplest one. And it generates the logic pulse and I am counting the number of pulses. Fine. Now what happens in the single channel analyzer? When we want to do the energy measurement and the multi-channel, I divide the entire voltage level into many LLDs and ULDs. What are LLDs and the ULDs? They are the lower level and the upper level of the single channel. And I call this SCA1, SCA2, SCA3, so on and so forth. These SCAs are counter 1, counter 2, so on and so forth. What we draw at the end is the number of counts per channel as the function of channel numbers. So let me just go through this. I'm pretty sure that you understand here. Hopefully you understand here. You understand it here. Up to the point that the CRRC network is used, you have understood it. After that, what we are doing? We are dividing it into many of those multi-channel analyzers have multiple SCAs. Each of the SCA works on the LLDs and the ULDs, the lower and the upper. What is the job? If the amplitude, not the voltage, amplitude of the pulse is between the two levels, then that will result in a logic pulse which will be counted by the counter. So, if in this case, if I look into it, most of my SCAs are not going to fire at all because the amplitude is going up to this point. So 1, 2, 3, 4. Most of them are fired by the ones which are at the SCA 4 or 5 level here. None of the SCA 1, SCA 2, SCA 3 can fire. Which means that I will write down here my what? Each of the channel number. So channel number 1, 2, 3, 4, 5, so on and so forth. And suddenly I will see, if I just look at the number of counts, you will see that most of them will be concentrated, okay, 1, 2, 3, 4, 5. In this case, most of them is going to give numbers here as the histogram. Some of it is going to give maybe here, some of them maybe here. But the one at the center will be the largest one. That will depend on if the sigma delta E turns out to be a huge number. So if E is 5 MeV, sigma turns out to be 1 MeV. So it is already what happens that I have 1 over 5, 20% uncertainty at the level of the detector itself. If there is 20% uncertainty here, my number 5 MeV can be shown as 4 MeV, 6 MeV, anywhere for a single alpha. Now, what I wanted to communicate last time, which was not clear to you, I am not interested in one single pulse. I am not interested in deconvoluting this to get the amplitude. Why? It's one alpha interacting in the detector. It may have its own, it could have been anywhere. How do I know that this was the perfect energy which was deposited? I cannot know it. So I am not interested in deconvoluting a single pulse here. What I am interested in seeing what most of the pulses are doing when the same energy particle is passing through. Remember, smaller is this number, sigma. They will all be restricted to only one SC. You can make it finer and finer by increasing what? Number of SCs, which means number of channels. You increase the number of channels. Each of the channel will be showing a smaller delta V. A smaller delta V means a smaller resolution. So you increase that. And then you will be saying, oh, if I am seeing now a very fine distribution limited here, then okay, my detector does a job in which it does not degrade the original energy by a huge amount. And I will say the resolution of the detector is good. But if with that nice SCAs arrangement, large number, if you get, for example, very distributed pulse, so which means that the sigma was very high, your detector might be very thin. Lot of electrons, delta electrons, they just got emitted without actually depositing energy. In that case, howsoever good your SCAs were, it's the detector which lost your resolution. So finding the detector resolution is done by looking at large number of channels, right, for a given energy source. That's how we are finally getting number of pulses. generated, which are the logic pulses, amplifiers, SEs triggered that, pre-amplifiers and the detector. This is the whole process which we discussed. We get this one from which we are getting the result. There are other problems also. If the source rate is not very high and you have large number of SCAs, which means very fine demarcation, large channels. But if there are not enough events in a single bin, then again you are facing a problem that even though the resolution is good, but the rate is so small that you wouldn't be able to tell much from that about the resolution. You will have to take that data for longer duration in order to generate statistics per channel. So make sure you understand our job is not to find out how good one event has given you the result. Our job is to find out when multiple numbers have gone through it, where my distribution is getting big, with what width. Width is decided by the channel's delta V to begin with and the detector's resolution. It will be dependent on those. Right? This is what we have done in this course. Yeah? That we started with source, we discussed interaction, we discussed detector, and then we made this kind. This is the final output in the energy measurement plots or the measurement for anything which we are doing. Questions here? Something which is not clear. So last time several students asked, sir, इस वाली एनर्जी ये तो आ गया ना आपके पास एक पल्स, इसको तो मैं बहुत अच्छे से देख सकता हूँ डिकन्वोल्यूट करके कितना इसका एम्पलीट्यूड है और कितनी विड्थ है। तो जब मैं इसको इतने अच्छे से डिकन्वोल्यूट कर सकता हूँ तो मैं बाकी सब को क्या कर रहा हूँ सर, ये नंबर सेट है। मुझे एक में कोई इंटरेस्ट ही नहीं है क्योंकि एक तो कहीं पे भी फॉल कर सकते हैं। मुझे कैसे पता था वो पहला वाला कहाँ फॉल करे? मुझे तो ये पता है कि ऑन एन एवरेज इट इज गोइंग टू फॉलो दिस काइंड ऑफ अ डिस्ट्रीब्यूशन। व्हाटएवर दिस डिस्ट्रीब्यूशन इज, अल्टीमेटली मैं चाहता हूं कि वो डिस्ट्रीब्यूशन यहां पे आ जाए। अगर ये डिस्ट्रीब्यूशन यहां आएगा तो इसका मतलब है मेरा मल्टी चैनल एनालाइजर अप टू दैट इलेक्ट्रॉनिक्स इज नॉट इंट्रोड्यूसिंग एनी अदर नॉइज। बट इफ देयर आर SCAs which are far off from each other, तो ये रिजोल्यूशन तो बहुत कम था, लेकिन यहां पे ये रिजोल्यूशंस बड़े-बड़े थे। यू डिड नॉट हैव मेनी चैनल्स। In that case, it's not this resolution which will be creating trouble to you. This resolution that the width of the SCAs are not sufficient in the LEDs and the ULEDs, that will be deciding factor. So it's two resolutions playing against each other. Your job as a nuclear physicist is to ensure whatever electronics you are using should not degrade the original resolution. Second job, how to improve upon this resolution. All you are doing is to improve upon those two, nothing else. The electronics engineers or the physicists improve upon this. Only physicists improve upon this. Nobody else can improve this. But it's a nice interplay. That's why you have electronics in the course. You cannot define the measurement setup for a nuclear experiment unless you have basics of these things here. Do I make a bit more descriptive and clear in terms of what we are trying to achieve in this one? Yeah. Now I am going to put my sections of the electronics which you are supposed to study for your exam. Yeah. But make sure you understand this portion. This is the final output and this is the original. Now, sir, source is the only way we get the particles. No, I can have accelerators. Why only natural radioactivity? Why not artificial radioactivity? We can use artificial radioactivity. We can have accelerators. So nuclear physics of course expands. Why Inter-University Accelerator Center is there, RR10 is there, BECC is there? They are using accelerators to come up with it. Reactors are there where the neutron-based triggering is happening so that the fission is happening. But make sure that this is still the picture. The picture is not going to be changed. Since my sigma is completely left over, So I want to devote my rest of 1.5 lecture only on that aspect. I do not want to hurry up, but whatever I want to communicate, practical aspects related with our nuclear physics, I hope that I will try to. In case if something is not clear, you ask there and then. There is no way everything in the book can be condensed in this way, but it is pretty clear that whole purpose that you went through mathematical physics course or the probability statistics and before that, because it will lead to this. It's almost like Kapil Sharma का question. आपने सोचा था जब आपको पहली फिल्म मिली थी कि आप कपिल शर्मा शो करना पाओगे? So आपने सोचा था जब आपने probability statistics शुरू करी थी कि आप सिग्मा डेल्टा ही उससे समझोगे? This is the reason why you did that. Mathematical physics, probability statistics, if for not everything else. Because my friend still asked me, जो मेरे साथ स्कूल में थे, यार ये a plus b whole square plus a square plus b square plus 2ab यूज कब किया हमने लाइफ में? इतनी मेहनत तो करी पर यूज कब किया? Yeah, they ask me all kind of questions. Professor बन गए हो तो बताओ सब कुछ. Supposedly senior professor. Okay, good. Easiest functional one, huh? Experiment, errors, error propagation. जहां पे I am losing you, you are going to raise the red flag. Sir, गया, आप गया ही नहीं, right? I do not want to deal that much. Question number 1. Experiment or measurement. I am measuring the length of this guy. Only the length. Yeah, so height, length, whatever you call it. I say this turns out to be, who cares? Can I say any one of them? सर मैंने लेंथ मेजर की है ऑलमोस्ट एक छोटे वाले फुटे के बराबर है 12 सेंटीमीटर का और ये नंबर है 12.3 सेंटीमीटर आई मेजर्ड इट सर मैंने स्केल यूज किया था मैंने मेजर किया सो कैन आई रिपोर्ट द रिजल्ट लाइक दिस नो द फर्स्ट वन और द सेकंड वन
फर्स्ट वन
in fact I cannot under no circumstance I can actually report this result neither this nor that why because even if you have to report it you will have to say sir, I have to report the uncertainty of the measurement. This is sigma of my scale, which is defined as the least count. The first point which I want to communicate to you, there is no way a measurement can be performed without error. Impossible. If it is theory, I have nothing against it. If it is experiment, if you report average value or single number, it won't work. 12.3 also doesn't work because I do not know which instrument you have used. This guy tells me the instrument, 0.1 centimeter. Make sure you are clear about that. First thing first, experiment or measurement cannot be reported without its error or uncertainty. Error is the wrong word. Because then I am saying कि मैं स्केल यूज कर रहा था पर मैं उससे चाह रहा था इतना कि वो लास्ट डिजिटल प्रिसीजन यूज करे स्केल की तो गलती नहीं है कि भाई मैं 0.1 सेंटीमीटर तक जाता राइट वो उसकी अनसर्टेनिटी है उसका लीस्ट काउंट आप लीस्ट काउंट से ज्यादा अच्छा रिजल्ट कोट करना चाहते थे आप स्केल छोड़ के कुछ और यूज करते बट स्केल के ऊपर दोष देना गलत है वर्ड एरर इज अ मिसनॉमर uncertainty is the correct word for any resolution related issue. It's the result and this is the uncertainty. Uncertainty is sigma's term. Now at this point I'll say if there are uncertainties, what are its types? One is what we call as the systematic ones and another is what I call as the practice बढ़ाओ statistical one systematic and statistical are the two uncertainties Let's just take the same measurement again. Scale. एक बच्चे ने मेजर किया, रिजल्ट सही रिपोर्ट किया, दूसरे बच्चे से अब आप करो। मैक्सिमम पैरेलैक्स का इशू आ सकता है। पैरेलैक्स मींस मैंने ऐसे नंबर देखना शुरू किया जबकि मैं मेजर ऐसे कर रहा हूं। I have not gone on the top of it without looking at the 2 points. That error is possible. But if all of you were careful enough that I am measuring like this, सर इसमें ना मैं कितनी बार भी मेजर करके रिजल्ट दूंगा, आपको सिर्फ और सिर्फ एक ही रिजल्ट में रिपोर्ट करने जा रहा हूं, वो ये सेंसिबल, राइट? और कोई अनसर्टेनिटी नहीं है सर आपके मेजर में। किस बात की अनसर्टेनिटी बना रहे हो? यही नंबर आ रहे हैं, दसों बार, हजारों बार सेम स्टूडेंट, अलग स्टूडेंट समथिंग है। What is it about the statistical one? What is happens to here? That means that there does not exist any other uncertainty in the overall system. Now the word uncertainty is subjective as well as objective. Using error, uncertainty, ऐसा लगता है एक नंबर कोड कर रहे हैं. But real uncertainty, for example, same experiment but not the scale one, I use the bar pendulum. अब कैसे किया? बार लिया, उसे स्मॉल एंगल डिफ्लेक्शन करना है भाई, एंड देन अ पर्सन इज जस्ट स्टैंडिंग समवेयर लुकिंग एट इट, कितनी बार ऑसिलेशंस हुआ, राइट? हाउ डू यू स्टार्ट इट? यू स्टार्ट विद समबडी होल्डिंग इट, स्टॉप वॉच, you release it. What happens in this? In this there is one external uncertainty. What is that uncertainty? Uncertainty is release. सर आपने स्टॉप वॉच में देर कर दी थी सर, बहुत स्लो आप तो क्या करें इसका? सर एक काम करते हैं, बार बार कुछ रिपीट करते हैं। उससे क्या मतलब है? इफ योर अनसर्टेनिटी इज रैंडम, व्हाट इज द मीनिंग? कभी मैं जल्दी स्टॉप वॉच प्रेस कर रहा हूं और कभी रिलीज जल्दी हो रहा है, सिस्टमैटिक बायस है तो ये प्रॉब्लम नहीं जाएगी। इफ दैट अनसर्टेनिटी इज रैंडम, समटाइम यू समटाइम आई विन, then in that case averaging takes care of it. But the interesting part is in the bar pendulum is the uncertainty is external. वो इसलिए built in है कि हमारे पास कोई तरीका नहीं सिंक्रोनाइज करने का। बट ओके, क्या कर रहे हैं? फैंसी लैब में चले जाते हैं, वहां पे as soon as this gets released, immediately the time piece starts. आप नहीं टच कर रहे उसे, मैकेनिकल और इलेक्ट्रॉनिक सिस्टम लगाया है। Now what will you do? सर ये रैंडम फ्लक्चुएशन बहुत कम होगा इसका, राइट? इन दैट केस एवरेजिंग इज नॉट गोइंग टू हेल्प यू मच बिकॉज द अनसर्टेनिटी यू हैव रिमूव्ड. देयर एग्जिस्ट अनदर वन व्हिच हैपेंस इन न्यूक्लियर डिकेज, व्हिच इज व्हाट we know it is governed by the quantum mechanical process. If I have a collection of 10 nuclei, each of which can decay with the average half life of 2 minutes, I ask you कि भाई